So let's start with our main topic, that is analog communication, and in that we are going to discuss now amplitude modulation. So as we have said that in analog communication we have two types of signal. There are two types of signal in the analog communication. In all over the analog communication we will have two types of signal. First one is called modulating signal, and it is also known as message signal or baseband signal, because it contains a band of frequency. So we will have two signals. First one will be our message signal, which is our low frequency signal or low pass signal, as we have discussed in the modulation part, and another will be your carrier signal. Carrier signal, and it will be AC cos omega CT plus phi. So we have two types of waveform. So as we have seen that there are two different definition for modulation we have seen, and the second definition was when characteristics of one waveform varies accordance with the characteristics of another waveform. So here we will have two types of signal in analog communication. First one is your message signal, second one is your carrier signal. Carrier signal is a high frequency signal, message signal is a low frequency or low pass signal. The importance of carrier is to carry the message signal for a longer distance, because if we throw suppose a paper which is our message signal, if we throw directly, then we cannot throw it very far distance. But if I wrap this paper in a stone and then throw that stone, then the paper will be for the longer distance, it will travel to the longer distance. So here the stone is our carrier signal and the paper is our message signal. So it carries the message signal to the longer distance. So that is the importance of carrier signal. And another importance, we have seen that it reduces the height of antenna, because it converts the low frequency message signal into a high frequency message signal, high frequency modulated signal. So there is another definition, which is characteristics of one waveform varies in accordance with the characteristics of another. So the characteristics of modulating signals are different. For a different message signal it is different, but the characteristics of carrier signal is constant. That is, either it will have some carrier amplitude, it will have some frequency, it will have some phase. So according to the message signal, this characteristic should vary, because this is random, this can be anything, but the characteristics of carrier signal is fixed. That's why we will change the characteristics of carrier signal according to characteristics of message signal. That will be the definition of modulation, another definition. So in amplitude modulation, if I change the carrier amplitude according to the message signal, keeping frequency and phase constant, it will be called as amplitude modulation. Okay, in amplitude modulation, amplitude of carrier signal varies in accordance with the modulating signal. In frequency modulation, frequency of the carrier signal varies in accordance with the modulating signal, keeping amplitude and phase constant. And the third definition will be for phase modulation. If the phase of the carrier signal varies in accordance with the modulating signal, it is called phase modulation. So these are the three types of modulation which we are going to discuss in analog communication, as I have told you in the introduction part. So let's start with the amplitude modulation. So our first chapter is amplitude modulation. So far we have discussed about the modulation and the block diagram of communication system, how the modulation converts the low frequency signal into high frequency signal, what are the importance of modulation, and now we are discussing about the modulation, another definition of modulation, in which we are saying that it is the characteristics of one waveform varies according with the characteristics of another. Okay. Now in analog communication we will have two types of signal. So according to that we are dividing it into two chapters. First one is amplitude modulation and second one is your angle modulation. First chapter is your amplitude modulation, and in amplitude modulation the procedure for to approach this chapter will be like this. We will start with the general equation of amplitude modulation. What is the general expression of amplitude modulation? Then we will talk about the parameters related to the amplitude modulation. What are the different parameters used in amplitude modulation? What is the time domain representation of amplitude modulated signal? What is the frequency domain representation of amplitude modulation? And from frequency modulated representation we can calculate the bandwidth of the signal, and from the expression of amplitude modulation we can calculate power required to transmit amplitude modulation. Types of amplitude modulation: double sideband, single sideband, vestigial sideband, phasor diagram, complex envelope, all these things will be covered. And then we will go to the next part of this chapter, that is the generation and detection part. Then what is the generation of AM, what are the circuits required to generate AM signal, how we demodulate the AM signal, how we can recover the message signal from the AM signal by different methods. Then same for double sideband suppressed carrier, and then same for single sideband suppressed carrier. So we will see all these different types of modulation in AM also, generation and detection. So we will start with the amplitude modulation, and we are starting with the general expression. So the general expression for amplitude modulated signal is given by the general expression of amplitude modulated signal is given by, I am representing the modulated signal by S of t, and S of t is equal to AC in bracket 1 plus K into MT cos omega Ct. This is the general expression of an AM signal. If a signal is AM, then it will be converted into this form. This is the general expression. This you should remember. Here AC is amplitude of carrier, MT is message signal, Ka is amplitude sensitivity of modulator, and its unit will be volt inverse, because here one is constant, it is dimensionless quantity. If the message signal is a voltage signal, then it should also have the multiplication of these two, should also have the dimensionless quantity, and for that this unit of this K should be volt inverse, so that this volt inverse and volt will be multiplied and will get dimensionless quantity, that is constant. If the message signal is voltage signal, then the unit of K will be volt inverse, and which we will gather most of the time, and this Fc is carrier frequency. So these different parameters we can calculate from the expression of AM signal, and also the most important one is envelope AC 1 plus KMT. This is called envelope of AM signal. It means that the message signal is lying in envelope of AM. So if we want to recover our message signal, we have to recover envelope of the signal. So this is the importance of this envelope, because we should know that where the message signal is lying, because at the receiver we have to demodulate the modulated signal and we have to recover the message signal, and for that we should know where the message signal is present. So this is the envelope AC1 plus KMT. Now the second parameter which is related to this expression is known as, or the second parameter which is related to this particular modulation is called modulation index. Now write the definition of modulation index. It is defined as measure of, how much, how much a modulating signal modulates the, carrier signal. How much a modulating signal modulates the carrier signal. So this is the measure of modulation index is nothing but the measure of how much a modulating signal modulates the carrier signal, up to the which depth it modulates the carrier signal. That's why it is also known as depth of modulation. Modulation index is also known as depth of modulation. Depth of modulation. So it is denoted by MA, or sometimes it is denoted by mu. You will find the different notation for this modulation index, that may be MA or that may be mu, and it is nothing but K into maximum value of MT. K into maximum value of MT. K into maximum value of MT. Now suppose we have one block, and in this block it is written that amplitude modulator, and at the input of this amplitude modulator we are giving our low frequency signal, modulating signal MT, and another signal is AC cos omega CT. Then we will get S of t, which is our AM signal, AC 1 plus KMT cos omega CT. Then the amplitude modulator is having modulator constant or amplitude sensitivity, that is Ka. So we will have two signals in the starting of analog communication. So MT and AC cos omega CT we are having. We are giving input to the amplitude modulator and we will get the AM signal. If this block is written like double sideband suppressed carrier modulator, then we get DSB SA signal. So S of t is equal to AC 1 plus KMT. There will be some calculation inside this block and we will get this type of signal at the output if the block is amplitude modulator. Now we will say what is the expression for single tone modulating signal. If our message signal is single tone, for single tone sinusoid modulating signal. Okay, for a single tone sinusoidal, it means that because most of the time we can convert our message signal into the sine and cosine terms, or our message signal can be represented in terms of sine and cosine. That's why we consider message signal as a sinusoidal signal most of the time. So the message signal MT is a single tone. Single tone means here is the signal which is having only one frequency component, and sinusoid means it may be a sine wave or cos wave. So by default we assume sinusoidal signal as AM cos 2 pi FM or omega mt. So this message signal is having amplitude AM, it is having frequency FM, which is a single frequency component, that's why we are calling it as single tone, and sinusoidal because we are taking sine or cos, either it may be sine or cos. So by default we will always consider cos signal. So if it is empty, then what is the modulation index? The modulation index is defined as k into maximum value of mt. So modulation index mu or MA will be k into maximum value of mt. Mt is AM cos 2 pi FMT. So the maximum value of this cos will be its amplitude, that is AM. So this is k into AM. So modulation index is k into AM for single tone modulating signal. There is another definition also for modulation index, and it is modulation index is also defined as ratio of amplitude of message signal to the amplitude of carrier signal for single tone sinusoidal. For single tone sinusoidal, we can also define the modulation index as amplitude of modulating signal to the amplitude of carrier signal. So if we compare these two equations, we get k equal to 1 by AC. As you can see that if we compare these two equations, this k should be 1 by AC. So k is 1 upon AC. K is 1 upon AC. So if k is not given in the question and we have the amplitude of carrier signal, then we can take k equal to 1 upon AC. If both are sinusoidal, carrier is sinusoidal and message signal is also sinusoidal, then we can take k is equal to 1 upon AC if k is not given. If Ka is not given in the question. If k is not given. If k is given, then 1 upon AC will not be applicable. We will consider the given value of Ka. If k is given, then we will not consider k equal to 1 upon AC. If k is given, then we will not consider k equal to 1 upon AC. This will not be valid. Okay? This is important point. If k is given, then we have to take that value of k. It may be possible the 1 upon AC may be different than the given value of k. So if the k is given, then we have to take the value of k. Suppose we have expression like 5 1 plus 0.5 mt cos 2 pi FCT, and message signal is mt is equal to 2 into cos 2 pi FM. Okay, suppose it is given S of t is equal to this one and mt equal to this one. Then because the expression of the AM signal is given, we can compare this equation to the standard equation, and our standard equation is AC 1 plus k mt cos omega ct. Then on comparing these two equations, we get k is equal to 0.5 and AM equal to 2. Then we will calculate modulation index MA equal to, because the message signal is sinusoidal, to k into AM. So k is 0.5 and AM is 2, that means we get modulation index MA equal to 1. So this is the value of modulation index and this will be the correct answer because the k is given. And if you apply modulation index AM upon AC in this question, then the AM is 2, AC is 5, you get 0.4, which is incorrect, okay. This will not be the correct because you are considering K equal to 1 upon AC, but the value of K is given, so you cannot consider K is equal to 1 upon AC. So this is not correct. Remember this one, कि if the value of K is given, then you cannot take K is equal to 1 upon AC, or you cannot apply AM upon AC, because the actual definition of modulation index is K into maximum value of MT. This is only valid when the K is not given, right? If K is not given, then only you can apply this formula. So next will be the expression of AM signal for single tone modulating signal. So if we substitute this value of MT in our general equation, which is S of t is equal to AC 1 plus K MT cos omega Ct, then we get S of t equal to AC in bracket 1 plus K into MT, MT is AM cos omega MT cos omega Ct. So K into AM we have calculated, it is a modulation index. So this is AC 1 plus MA cos omega MT cos omega Ct. So this expression you should remember again, because this is very important because of single tone modulating signal, because our most of the message signals will be single tone modulating signal or multi-tone sinusoidal modulating signal. So this type of expression in which there is a cos or sine, the coefficient of cos and sine will be the modulation index corresponding to that frequency. If there is one frequency, that is FM only, then the corresponding coefficient will be the modulation index for that frequency FM. So this is the expression of AM signal. Next we will see the time domain representation of AM signal.